Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and today we are continuing our video series on how to write a PSMT, a problem-solving modelling task. And this is our 10th video in the series where we're going to be looking at relevance, strengths and limitations of the solution as part of the 2025 syllabus update. Now before we get started, I wanted to let you know how you can engage further with McClutchy Maths. There's a few different ways. First of all, you could like and subscribe and hit that notification bell so you'll always know when the next video is available. You could consider telling someone about the channel or even sharing it with them on social media or sending an email of the link to the video to a work colleague or a friend or family member. If you have a OneNote and you're a teacher, why not consider putting the links to these videos on your OneNote so your students can quickly access them. You could consider following us on social media. We're on Facebook and Instagram. And now YouTube has a feature where you, who has had your bacon saved by this video, you can actually give back to the channel. A couple of dollars helps us to keep the running costs of the video and of producing the videos going. Well, here we go with our ISMG, the Instrument Specific Marking Guide. And we are looking at these two dot points. They're called performance descriptors in the evaluate section of the assignment. Now, this is an important part of the assignment. It's worth 5 marks out of a possible 20. So a quarter of your grade is coming from this box here. And we're going to focus on these two parts in this video: justified statements of relevant strengths of the solution, justified statements of relevant limitations of the solution. So there's some keywords here we're going to unpack. We've got the word justified, we've got the word relevant, we've got strengths and limitations, and of course this focus on the solution. Now, if we don't achieve in this 4 to 5 range, we're going to drop down to the 2 to 3 range, where we're going to be making statements of a relevant strength or relevant limitation of the solution. So let's have a quick look at how these differ. First of all, you'll notice this one is not justified. It's simply a statement with no explanation. Let's have a look now at how these two differ. This one here's got the word justified, whereas this is simply a statement. So there's no explanation as to what effect these strengths and limitations have on the solution. So that's the first part that's missing. The next part that's missing is we've got plural up here. So that means we need at least 2 strengths and at least 2 limitations. Notice down here we've simply got a statement. Now up here we've got both of these dot points here, strengths and limitations. Down here we've got one or the other. So if you forget to do your strengths, you won't get this one here. If, let's say, you've forgotten your strengths, but you did one limitation, well, you won't go there, but you'll go here because you've got one or the other. Okay, and if we miss that box, we hit down in that one performance range, which is down here, a statement of a strength or a limitation. Now, how this differs is that there's no mention of the solution. So this might be something that's not a strength or a limitation of the solution, but it might be a strength or a limitation of something else. In the past, you weren't awarded marks for that, but now you can actually achieve in that one performance range there for giving a strength or a limitation of something else. And we'll talk about what those something else's are later in the video. Okay, first of all, let's focus on what a strength is. It's an aspect of the solution that makes the model be able to be used for its created purpose. So a model being an equation or a graph, you can actually use that to do a prediction or to make a comment on a correlation, to say that there's a relationship between 2 variables. So you can actually use it for what it's made for. It can be applied to other situations. So if you've come up with a solution that has applicability in a range of different scenarios, then it's a strength of the model or the solution that you've created. If it actually has modeled the data accurately, then that could be a strength of the particular solution that you've come up with. There could also be aspects of the solution that make it useful for its purpose, including things like the ability of the model to make predictions with a high degree of accuracy and precision. So if you've got a model that has, for example, strong correlation, or that you've confirmed that it is a linear or a non-linear model, and then you can rely on that for interpolation predictions, then you have something that is useful for its purpose. As I've just mentioned, it's interpolation only. Remember, anything that's extrapolated or that's making predictions outside the data range that you've measured, well, that is not a strength, an extrapolation prediction, because extrapolation predictions are always unreliable. I've also mentioned that if you're doing bivariate data analysis and you've ended up with high correlation, or you've done a residual plot that confirms you've got linear modeling happening there, either of these situations are individual strengths. So if you've done bivariate data, you came up with moderate or strong correlation, talk about it here in this part of the assignment. You've come up with a strength. Or if you did a residual plot and it confirmed linear model, then this is another strength you can talk about. Also, your methodology, your procedure, the steps that you took to complete the assignment, these can also be aspects of your assignment that are strengths. So for example, let's say you selected a sample size using mathematics. Maybe it was 10% of the population, maybe it was using the square root of the population method or another valid formula. That's a mathematical selection, so that means that you've got a decent sized sample. That could be a strength that you talk about in this part of the assignment. Or the composition, let's say you use stratified sampling, which means that you had 50% males, 50% females, or 20% year 7s, 20% year 8s, 20% year 9s, 20% year 10s, 20% year 11s. That could be a strength of the model because you've got this structure to this composition or the makeup of your sample that makes it reflective of your population or representative of your population. That's a strength. Let's say you've done verification as part of your verified results and you confirm the accuracy of your model using a different method. That is appropriate methodology. Can't England today. So that appropriate methodology is going to be part of a strength of your assignment. Now, there's something very important here though, that you're not writing about strengths of technology. Okay, you're writing about strengths of your results. So the technology that you use is not your result. So if you do end up talking about the strengths of your technology, and an example of that would be to say, Excel made it very easy to draw a graph, or Excel made my calculations accurate. That's not technically a strength of the results, unless you then go on to talk about the importance of the accuracy. There's ways to get around that. But when you're talking about how good Excel is or how good your calculator is, you're going to end up in that 1 out of 5 range because it is a strength, it's just not strengths of results. So be very careful there. Other things that you could consider as part of your appropriate methodology. If you're doing an experiment and you did keep control variables the same. So let's say, for example, you were doing an assignment on a geometric sequence. That might have been one of your topics. And you might have had to do how boiling water cools down and how quickly it cools down. Now, it actually cools in a geometric sequence. It's a geometric decay. Now, when you're looking at that boiled water or boiled coffee or boiled tea and how quickly that cools down, you might have done that and kept all your control variables the same in every circumstance. So you might have made sure the room had the exact same temperature on the external air that was coming into contact with the coffee or the tea. You may have made sure it was in the same strength of coffee or strength of tea each time. You may have made sure it was in the same coffee mug each time. So you kept all those other control variables the same perfectly every single time. That is appropriate methodology. That could be a strength of your assignment and make your model easy to rely upon. Things like lack of confounding variables. So remember from your studies that confounding variables are variables that have an effect on either just your explanatory your response variable, your y-axis, or it could be variables that affect both. If there was a situation where there weren't many or very few confounding variables or even no confounding variables, that's a strength of your response. Now let's talk about limitations. Obviously, a limitation is the opposite of a strength. So these are aspects of your solution that prevent or make your model less useful for its purpose. So a limited model is not useful for making predictions. It makes it very difficult if you were asked a question in the assignment to answer that with 100% confidence. Okay, so extrapolation. If you've done any predictions using extrapolation are predictions outside the values of what you've measured. So an example of that might be that you might have only measured people in the range of height of 150 to 180 centimeters. But if you're now making a prediction of using your model of somebody who's 2 meters tall, it's outside what you've measured, it's extrapolation, it will always be unreliable. That prediction itself is one of your results, and so therefore that's limited by the fact that it is extrapolation. Other considerations of things that limit your models or solutions include if you have outliers and you decided to keep those in because they were real life calculations that were accurately calculated, those presence of the outliers could skew your results, it could reduce your correlation, so those outliers themselves could be limitations on your results. If you did start with a small sample size, so let's say you did use a mathematical method to calculate that sample size, but it still came up at a sample size of 12 or a sample size of 15, that is quite a small sample. Even though it might have been calculated using a mathematical method, it was still too small to make generalizations about your results, so that would be a limitation. If your sample wasn't representative of the population, so we've used an example in the past of calculating the measurements of celebrities' faces and coming up with a model to make predictions. Now the reality is that is only going to be useful for making predictions of other celebrities, because celebrities are a very select proportion of the population who are typically more beautiful or more aesthetically pleasing to the eye, and so therefore they are not representative of average Joe on the street. So that would be that you would not be able to use your model about celebrities to make generalizations about other people in the world. So that might be a limitation of your model. If there were variables that you didn't control, so I'll go back to my coffee and tea example. Let's say you did the experiment on different days and the temperature might have been different. There might have been different humidities. That might affect your results. It might have been a variable that was not controlled. If you use different coffee mugs each time to try and measure how long it took for your coffee or tea to cool down to a particular temperature, then the different coffee mugs might have conducted heat differently and therefore they weren't controlled variables. Or you might have a situation where you have a lot of variables that confound the results. They affect both the response and the explanatory variable or just one of those variables. So those confounding variables have an effect, so therefore they will limit your results. Other things that limit models and solutions include things like low correlation or no correlation at all. So it's very hard to use your model to make predictions if you've got 10% correlation or correlation of 0.1. If your residual plot indicated that there was a nonlinear model and you're doing a bivariate linear analysis, then this is going to be an issue because Pearson's correlation coefficient is only designed to be used on linear models. And also that means R squared is affected, and you can't use an equation y equals a plus bx or y equals mx plus c or y equals mx plus b in a situation where you've got a nonlinear model, because a nonlinear model has powers. So if you're using a model that's only designed for straight lines and your residual plot shows it's actually nonlinear, then it throws all the work you've done out the window, and that's very limiting indeed. If you're doing an assignment on budgeting and you ended up with an overspent budget, then that's a limitation because the person cannot survive on the budget that you've created using all of those observations and assumptions that you did to create that budget. If you had to come up with a design such as a renovation plan, a floor plan, a scale model, a recommendation for a solar system, something like that, and that design doesn't actually meet the requirements of the task, then that is a limitation as well. If you've got domains that you've created for a methods assignment and those domains have limited your model to certain ranges and you actually want to use predictions outside those ranges, once again, that's a form of extrapolation. That is going to limit your results as well. Okay, we're now going to have a quick look again at the ISMG and some of the different words in there. So we did talk about this earlier. To be able to achieve in this 4 to 5 range, you need to make multiple statements. That means at least 2 strengths and at least 2 limitations. They need to be plural. If you do one only, you drop straight away to the box down here. So you need more than 2 or 2 or more. Now on balance, they need to be justified. They need to have an explanation about how results were affected. They need to be relevant and actually part of the solution. So you need to make sure that you don't go crazy and go overboard and list hundreds. I would say 2 to 4 justified relevant strengths and 2 to 4 justified relevant limitations would be enough. Any more than that and you're running the risk that on balance they are not. So what I mean by on balance, let's say you do 10 and only 3 of them are justified and relevant. Even you might say, well, I've done plural, I've done 10, but 7 of those were not justified and relevant. So then straight away, you are not hitting this justified criteria, and even though you've done the work for 10, you've moved down to the 3 range. So you definitely want to make sure that you don't do too many. This is a case of less is more, and make sure that they're just really well done. So what I've said here, it's not a case of the more the merrier. It's about ensuring that every one of them has been carefully considered and written well. So that's down to you, focusing on those 2 to 4 and doing a good job of them. Okay, the next thing is we need this justification. I've mentioned this a few times. I've also talked about it across the videos because this word justified spans all 4 of the criteria of the PSMT. So that means you need an explanation as to why the strength is a strength and why the limitation is a limitation. It's not just enough to say, I had 0.8 correlation and that's a strength. Why is that a strength? What impact does it have on the results? The next thing is it needs to be relevant. Okay, so this is a feature here, relevance. It's not a feature down here. So if these strengths and limitations actually aren't relevant to the solution, you'll automatically drop down to the 2 to 3 range. We've used that word relevance as part of formulate. You remember that when we created our observations and assumptions. So they need to actually relate to the task and have an impact on results. Now, it doesn't mean that your strengths and limitations have to relate to your observations and assumptions. Now, that's an important thing to note because the last time we looked at that word relevant, it was in relation to the formulate section of the assignment, talking about observations and assumptions. But your strengths and limitations don't have to be connected to the observations and assumptions if you don't want them to. So we've talked about some different things. For example, interpolation and extrapolation predictions, correlation, linear models, that sort of thing. That actually isn't necessarily an observation and assumption that you've made at the beginning of your assignment. So you can talk about strengths and limitations that aren't part of those observations and assumptions. It just means it needs to have a direct bearing or impact or effect on the results of your study. The last one is, to be in this range, it has to be of the solution. Okay, so you have to be talking about the solution or the results of your assignment in order to get this 4 to 5 range for your one. So it's not strengths and limitations of the technology. It's not strengths and limitations of the time constraints you had to complete your assignment. I have seen that before. It is not of your own personal strengths and limitations. I have seen students write things like, I'm not very good at using the calculator and I can't remember how to do it, and that was a limitation. That's not part of the solution. So if you are talking about these in a singular form or you didn't justify it, then only this range here is possible. So we want to make sure we do everything possible to get in that 4 to 5 range and guarantee us a good result. However, they need to be relevant to get in this range here, and they still need to be of the solution to get in that range there as well. So if we miss the relevance and we miss the solution, we're automatically dropping into 1 out of 5. So the big difference there is that people have not written about the relevance of the solution and they've gone straight to that box. Okay, questions I get is, how do I set it up? What's a good way to set it up? I think personally, doing it in a table is an excellent use of white space. You've only got a limited page number that you can write your assignments to, and often if you do things as lists, you'll have half the page that's disappearing there and not being used. It's just white space. So a good way to set it up is in your table. You can use dot points. It doesn't need to be full sentences. However, it is hard to do an adequate justification without writing a few sentences for each strength and each limitation. So you can put the things in dot points, and dot points don't have to mean that they're abbreviated words or abbreviated sentences. You can still write full sentences as dot points, but dot points is a good way to actually break down all of the different strengths and limitations and also show where one strength ends and the next strength begins. Consider that signposting as well. We talk about signposting in our previous videos. What I mean by that is you've actually used language that tells your teacher that you're talking about a strength and you're talking about a limitation. So here's an example from the QCAA's exemplars, a strength of the model. Okay, so they've actually used the word strength to indicate it's a strength. So if you're not going to use a table where you've got the heading strengths and you're listing the strengths one by one, then if you're going to write in paragraphs or sentences, use the word strength so that your teacher knows exactly what you're talking about. And the reason for this is that sometimes a particular part of your assignment could be a strength and a limitation. Now, you're not going to get credit for both unless you talk about it in both contexts and explain why it's a strength and why it's a limitation. Okay, so here are some more examples. I'm going to show you some examples from QCAA exemplars as well as student examples. So in this particular case, they have justified, and justification is important. So they've talked about here that it satisfied the assumptions, and they've also talked about what that means. They could use the model for its purpose to determine each competitor's position, and it resulted in a reasonable or plausible value. So that was a strength. The model could be used for its intended purpose. Here's a justified limitation done by a student. As the data contained outliers, this produced inconsistency in the data collection process. The data would have been more accurate if it had been measured personally with a specific data collection method. So we've actually got two limitations here. One here is that there's inconsistency in the data because of the outliers. The second limitation here is because there would need to be more accuracy. Now, if I was rewriting these limitations for that student, I would suggest they break that out into separate dot points so that it can be very clearly seen that there are two limitations there. Otherwise, your teacher could miss over that and see that you think you're talking about just the one dot point. Here's another one from the QCAA exemplar. A strength of the model is that a large sample from the whole cohort was used. This could have been improved by talking about why a larger sample would be better or how it improved the results. It could have been even supported by a source. So this is more of a statement. There's no real justification there. Without the justification, you don't hit that 4 to 5 range. So I've actually taken this one that the QCAA has used as part of their exemplar, and I've justified it. So a strength of the model is that a large sample of 30, being 10% of the whole cohort, was used. And now I've got a quote: a good maximum sample size is usually 10% as long as it does not exceed 1,000. And that comes from toolsfordev.org 2021. So now I've justified my strength. Here is another student example, student 2. They've got a limitation here that has not been justified. They've simply said car types are not separated into graphs. So this would have been good if they explained why it limited the results. So here I've done the justification for them. Car types are not separated into graphs. Had the car sample been split into separate studies of sedans, hatchbacks and sports models, the correlation for each would potentially have been stronger, making the model more suitable for making predictions. You can see that this is kind of like the lazy approach. Here, the student's actually done some work, or in that case me, I've done some work to actually think about how that has limited and what could have been done better, how that would have affected the results in a better, more positive way. So this extra work here is the justification. Okay, so here's an example now of a lack of relevance. I'm going to read this out. Limitations of the model is when trying to calculate and make a formula to calculate the price of the car, blah, blah, blah. But when I calculated, it was not what was in Excel, which shows the data wasn't accurate. Now, the issue here is that this student has gone and done this manually using the formulas for A and B, and notice their intercept here is out by 7. That's actually an error that they've made. They would have been potentially penalised in the solve section of the assignment for not doing it accurately. This is not a limitation. The fact that you've made mistakes or errors in your assignments is not a limitation. You need to fix them up when you're doing the assignment. If you've made mistakes and you're personally inaccurate, you need to fix them. Go back to the solve section and fix it. Then you can actually say it's a strength because it's accurate. Okay, another one about your personal situation. This student here, student 4, has said they had a lack of internet access, which is a little bit sad when you're doing your assignment because you sometimes need the internet to be able to do limited amounts of research. In that particular case, they needed to solve that problem themselves. If they had a lack of internet access, they should have maybe done their assignment in the library after school, where they could have accessed the school Wi-Fi, or done it at a friend's place or something like that. So the fact that your personal circumstances not being able to let you do the assignment well is not a limitation of the solution. That's a limitation of your own ability to write assignments. So don't go there. That's not relevant. Things like task constraints as well. So sometimes, most assignments in senior will have a limited number of lessons where you'll get to work on it in class. You'll get 3 hours of class time, and that's it. In junior, you might get more time to write assignments. This person here has said, if we had more time, we could have done more to benefit to benefit your final answer. Well, time constraints or restraints as conditions of your problem-solving modelling task are not relevant to the solution. They've also said they didn't have enough equipment, and that hindered their ability to come up with a range of equations. I'm sorry, but that is not a relevance to the solution. So they're things you just should have solved. I also see this one as a strength. Excel's a reliable program. Your strengths of your technology are not relevant, but I did say earlier there is an exception to that. If you've done some algebraic techniques and then you've verified that or confirmed your results using technology, not only are you going to hit verified results under the solves and the evaluation section, but then you're also going to be able to talk about it as a strength. But just saying that in itself is not enough. You actually need to talk about how this verified your results and confirmed the accuracy of your algebraic techniques. So there needs to be a lot more there to justify that adequately. I also see this one on occasion as well. There's no strengths, there's none at all, or there's little to none. Now, the thing is, your teacher would never have written this assignment if they couldn't have come up with some strengths, at least 2. So you need to think more deeply. If you can't think of enough, go and ask some questions of your peers, go and ask some questions of your teacher and say, I'm having difficulty coming up with strengths. Your teacher should give you some probing questions. They shouldn't answer it for you, but they should lead you so that you can come up with those answers yourself. Also, I would recommend going on and having a look at those QCAA exemplars. Watch this video series for ideas. Go back to, if you're doing an assignment on bivariate data analysis, go back and watch the video series, because sometimes I talk about strengths while I'm talking about different things that I find. So there's lots of resources for you out there. You just need to not be lazy and go and find them for yourself. Here's a little tip. This is one of the parts of the assignment that I see done usually the poorest, because we've run out of time, or we got bored of writing the assignment, or we did it the night before, heaven forbid. So I would recommend that you start that assignment on time and early. Try and get as much of it done as possible by the time of the draft date. So after the draft date, your assignment's virtually finished. You're just implementing the feedback from your teacher. However, if you've not got to this section of the assignment, there's no feedback the teacher can give you. So for example, if you had taken the time and got that to your teacher as an almost complete assignment, and they see that your strengths are not justified, your teacher will give you feedback. You need to justify your strengths. And that tells you, oh, okay, I'm missing something there. I need to do more work in that particular section. But if you leave it to the night before and you forget to justify, there's no feedback and no help for you at that stage of your assignment. Just remember, as I've mentioned already a couple of times, this part of your assignment is a quarter of your grade. And this is student 8's submission. They haven't done any of this. So they've missed 5 marks out of 20 straight off the bat. Probably missed because they've got no conclusion, probably missed some communicate grade as well. Very sad. So please make the time to get your assignment done and get it done early. Well, that's all we have time for in today's video. I hope you found this really helpful. If you've got any questions at all about anything you saw or heard, mcclutchymaths@yahoo.com, and we'll endeavour to get back to you as quickly as we can. Well, you've been watching McClutchy Maths. I'm Natalie McClutchy. Have an amazing day.